Namaskar. A very warm welcome in today's session on toxicology of heavy metals. In this session, I, Professor Shachi Shah from School of Interdisciplinary and Transdisciplinary Study IGNOU, will give you a brief account of sources of metals in the environment, their exposure to human, toxic effect of metals, common toxic mechanism and sites of action, and mechanism of toxicity and carcinogenicity of arsenic, cadmium, chromium, lead and mercury, which are 5 most toxic metals into the environment. To begin with, toxicology can be defined as a branch of science that deals with poisons, and a poison can be defined as any substance that causes a harmful effect when administered either by accident or by design to a living organism. Metals and their compound have long been recognized as important toxic agent, causing acute and chronic poisoning cases in occupational setting and in environmental high exposure situation. There are at least 20 metals or metal-like elements that can give rise to well-defined toxic effect in humans. The widespread use of metal, which has expanded substantially in the last century, has given rise to the widespread exposure of humans. The information on metal toxicity in human is derived from industrial health as well as large-scale severe episodes of poisoning via contaminated drinking water and food. For example, methyl mercury, cadmium, lead, etc. Arsenic, cadmium, lead, manganese and mercury have been studied most thoroughly, but other metals are also of concern like molybdenum. It brings about gout-like sign. Aluminium, it has shown to have serious effect on the central nervous system under certain circumstances. Likewise, antimony and cobalt, they may have effect on the cardiovascular system. In the past, clinical symptom of metal poisoning occurred in heavily exposed industrial workers. Such poisoning, it may be acute or chronic, and it involves a large number of organ systems. For example, gastrointestinal, lead colic, or neurological and hematopoietic symptoms and signs occur in lead poisoning. Bronchitis and skin rashes may occur in worker inhaling arsenic trioxide. Tremor and neuropsychiatric symptoms may be caused by excessive exposure by inhalation of metallic mercury vapor. Likewise, if inorganic mercury salt are inhaled, there may be renal damage in severe cases which may lead to anuria. The neurological symptom, it may include tunnel vision, ataxia, speech and hearing difficulty. It can occur in the population of, for example, Minamata, Japan, after the consumption of high doses of methyl mercury, which is through via contaminated fish, which is also known as Minamata disease. Likewise, skeletal decalcification with multiple fractures, anemia and kidney damage was seen after the long-term ingestion of high dose of cadmium, which is known as Itai disease. Those symptoms or syndromes characterizing specific forms of metal poisoning were identified in the past, but cases may still occur accidentally or where there is failure of preventing measure. In recent years, there has been an increasing ecological and global public health concern associated with environmental contamination by these metals. Also, human exposure has risen dramatically as a result of an exponential increase of their use in several industrial, agricultural, domestic and technological applications. Now I will discuss sources of metal. The reported source of heavy metal in the environment, they include geogenic, industrial, agricultural, pharmaceutical, domestic effluent and atmospheric sources. Environmental pollution is very prominent in point sources areas such as mining, foundries and smelters and other metal based activities. Although heavy metals are naturally occurring elements that are found throughout the earth crust, most environmental contamination and human exposure result from anthropogenic activities such as mining, smelting operation, industrial production and use, domestic and agriculture use of metal and metal containing compound. Environmental contamination can also occur through metal corrosion, atmospheric deposition, soil erosion of metal ions and leaching of heavy metals, sediment resuspension and metal evaporation from water resources also go to soil and groundwater. The natural phenomenon such as weathering and volcanic eruption have also been reported to significantly contribute to heavy metal pollution. Coming to industrial sources, these include metal processing in refineries, coal burning in power plant, petroleum combustion, nuclear power station and high tension lines, plastics, textiles, microelectronics, wood preservation and paper processing plants. Now coming to the toxic effect of metals, the heavy metals such as arsenic, cadmium, chromium, lead and mercury, they occur naturally. However, anthropogenic activities contribute significantly to environmental contamination. These metals are systemic toxicant known to induce adverse health impact in humans, which include cardiovascular diseases, developmental abnormalities, neurological and neurobehavioral disorder, diabetes, hearing loss, hematological and immunological disorder and various types of cancers. Talking about the main pathways of exposure, they may include ingestion, inhalation and dermal contact. The severity of adverse effect is related to the type of heavy metal and its chemical form and also time and dose dependent. Among many other factors, speciation play a key role in metal toxicokinetics and toxicodynamics and is highly influenced by factors such as valency state, particle size, solubility, biotransformation and chemical form. Several studies have shown that toxic metal exposure causes long-term health problem in human population. Although the acute and chronic effects are known for some metals, little is known about the health impact of mixtures of toxic elements. Toxic elements, they may interfere metabolically with nutritionally essential metal such as iron, calcium, copper and zinc. Simultaneously, exposure to multiple heavy metal may produce a toxic effect that is neither additive, neither antagonistic or either synergistic. In biological system, heavy metals have been reported to affect cellular organelles and components such as cell membrane, mitochondria, lysosome, endoplasmic reticulum, nuclei and some enzymes involved in metabolism, detoxification and damage repair. Metal ions have been found to interact with cell component such as DNA and nucleoprotein, causing DNA damage and conformational changes that may lead to cell cycle modulation, carcinogenesis or apoptosis. Now I will discuss some common toxic mechanism and sites of action. The first one is enzyme inhibition or activation. A major site of toxic action for metal is interaction with enzyme, resulting in either enzyme inhibition or activation. The two mechanisms are of particular importance. Inhibition may occur as a result of interaction between the metal and sulfur hydryl group, SH group on the enzyme, and or the metal may displace an essential metal cofactor of the enzyme. For example, lead may displace zinc in the zinc dependent enzyme alpha aminolevulinic acid dehydratase, which is known as ALAD, thereby inhibiting the synthesis of heme, which is a very important component of hemoglobin and heme containing enzyme such as various cytochromes. The second is carcinogenicity. A number of metals have been shown to be carcinogenic in humans or animal. Arsenic, certain chromium compound and nickel are known human carcinogens. Beryllium, cadmium and cisplatin are probable human carcinogens. The carcinogenic action in some cases is thought to result from the interaction of the metallic ion with DNA. The third is subcellular organelle. Toxic metal may disrupt the structure and function of number of organelles. For example, enzymes associated with the endoplasmic reticulum may be inhibited. Metals may be accumulated in the lysosomes. Respiratory enzymes in the mitochondria may be inhibited, and metal inclusion bodies may be formed in the nucleus. Kidney. Because the kidney is the main excretory organ of the body, it is a common target organ for the metal toxicity. Cadmium and mercury in particular are potent nephrotoxicant. The next is nervous system. The nervous system is also a common target of toxic metal, particularly organic metal compounds. For example, methyl mercury, because of its lipid soluble, radially crosses the blood brain barrier and enters the various nervous system. By contrast, inorganic mercury compounds, which are more water soluble, are less likely to enter the nervous system and are primarily nephrotoxicant. Likewise, organic lead compounds are mainly neurotoxicant, whereas the first site of inorganic lead is enzyme inhibition. Specifically enzymes which are involved in heme synthesis. The sixth one is endocrine and reproductive effect. Because the male and female reproductive organs are under complex neuroendocrine and hormonal control, any toxicant that alter any of this process can affect the reproductive system. Metals can act directly on the sex organ. For example, cadmium is known to produce testicular injury after acute exposure, and lead accumulation in the testes is associated with testicular degeneration and inhibition of spermatogenesis. The seventh one is respiratory system. Occupational exposure to metal in the form of metal dust makes the respiratory system a likely target. Acute exposure may cause irritation and inflammation of the respiratory tract, whereas chronic exposure may result in fibrosis, specifically aluminum, or carcinogenesis, which is caused by arsenic, chromium and nickel. The next one is metal binding protein. The toxicity of many metals such as cadmium, lead and mercury depend on their transport and intercellular bioavailability. This ability is regulated to a degree by high affinity binding to certain cystosolic proteins. Such ligands usually possess numerous sulfhydryl binding sites that can outcompete other intracellular proteins and thus mediate intracellular metal bioavailability and toxicity. These intracellular sinks are capable of partially sequestering toxic metal away from sensitive organelles or portion until their bind capacity is exceeded by the dose of the metal. Now I will discuss the main sources and mechanism of toxicity and carcinogenicity of arsenic, cadmium, chromium, lead and mercury, which are 5 most toxic metals. First is arsenic. Arsenic is a ubiquitous element that is detected at low concentration in virtually all environmental matrices. The major inorganic form of arsenic include the trivalent arsenite and in the pentavalent arsenate. The organic forms are the methylated metabolites, monomethyl arsenic acid MMA and dimethyl arsenic acid, that is known as DMA, and trimethyl arsine oxide. Environmental pollutant by arsenic occur as a result of natural phenomena such as volcanic eruption and soil erosion and anthropogenic activities. Several arsenic containing compounds are produced industrially and have been used to manufacture products with agricultural application such as insecticide, herbicide, fungicides, algicide, sheep dips, wood preservative and dyestuffs. They have also been used in veterinary medicines for the eradication of tapeworm in sheep and cattle. Arsenic compounds have also been used in the medical field for at least a century in the treatment of syphilis, yaws, amoebic dysentery and trypanosomiasis. Arsenic based drugs are still used in treating certain tropical diseases such as African sleeping sickness and amoebic dysentery, and in veterinary medicine to treat parasitic disease including filariasis in dogs and blackheads. Contamination with high level of arsenic is a major concern because arsenic can cause a number of human health. Several epidemiological studies have reported a strong association between arsenic exposure and increased risk of both carcinogenic and systematic health effect. Interest in the toxicity of arsenic has been heightened by recent report of large population in West Bengal, Bangladesh, Thailand, Mongolia, Taiwan, China, Mexico, Argentina, Chile, Finland and Hungary that have been exposed to a high concentration of arsenic in their drinking water and are displaying various clinico-pathological conditions. These cardiovascular and peripheral vascular diseases, developmental anomalies, neurological and neurobehavioral disorder, diabetes, hearing loss, portal fibrosis, hematological disorder and carcinoma. Arsenic exposure affects virtually all organ systems including, as I have told you, cardiovascular, dermatological, nervous system, renal, gastrointestinal and respiratory system. Researcher has also pointed in significantly higher standardized mortality rate for cancers of the bladder, kidney, skin and liver in many areas of arsenic pollution. The severity of adverse effect is related to the chemical form of arsenic and is also time and dose dependent. Now I will discuss the mechanism of toxicity and carcinogenicity. Analyzing the toxic effect of arsenic is complicated because the toxicity is highly influenced by its oxidation state and solubility as well as many other intrinsic and extrinsic factors. Several studies have indicated that the toxicity of arsenic depend on the exposure dose, frequency and duration, the biological species, age and gender as well as individual susceptibility, genetic and nutritional factors. Most cases of human toxicity from arsenic have been associated with exposure to inorganic arsenic. Inorganic trivalent arsenic is 2 to 10 times more toxic than the pentavalent arsenate. By binding to thiol or sulfur group on proteins, it can inactivate over 200 enzymes. This is likely mechanism responsible for arsenic widespread effect on different organ system. Arsenic 5 can replace phosphate which is involved in many biochemical pathway. One of the mechanisms by which arsenic exerts its toxic effect is through impairment of cellular respiration by the inhibition of various mitochondrial enzymes and the uncoupling of oxidative phosphorylation. Most toxicity of arsenic result from its ability to interact with sulfur group of proteins and enzyme and to substitute phosphorus in a variety of biochemical reaction to inactivate enzyme such as dihydrolipoyl dehydrogenase and thiolase, thereby producing inhibited oxidation of pyruvate and beta oxidation of fatty acid. The next metal which I will discuss is cadmium. The cadmium is a heavy metal of considerable environment and occupational concern. It is widely distributed in the earth crust at an average concentration of about 0.1 mg per kg. The highest level of cadmium compound in the environment is accumulated in sedimentary rocks and marine phosphate, which contain about 50 mg of cadmium per kg. Cadmium is frequently used in various industrial activity. The major industrial application of cadmium include the production of alloy, pigment and batteries. Although the use of cadmium in batteries has shown considerable growth in recent years, its commercial use has declined in developed countries in response to its environmental concern. The main route of exposure to cadmium are via inhalation or cigarette smoking or by ingestion of food. Human exposure to cadmium is possibly through a number of several other sources, including employment in primary metal industries, eating contaminated food, smoking cigarettes and working in cadmium contaminated workplaces, with smoking being a major contributor. Other sources of cadmium include emission from industrial activity, which include mining, smelting and manufacturing of batteries, pigments, stabilizer and alloy. Exposure to cadmium to human is commonly determined by measuring cadmium level in blood or urine. Blood cadmium reflect recent cadmium exposure, either from smoking, for example, or blood and urine cadmium level are typically higher in cigarette smoker, intermediate in former smoker and lower in non-smoker. Cadmium is also present in trace amount in certain food such as leafy vegetable, potatoes, grains, seeds, liver and kidney of crustaceans, mollusks, etc. In addition, foodstuffs that are rich in cadmium can greatly increase the cadmium concentration in human bodies. Examples are liver, mushroom, shellfish, mussels, cocoa powder and dry seaweed. Now I will discuss the molecular mechanism and toxicity and carcinogenicity of cadmium. Cadmium is a severe pulmonary and gastrointestinal irritant which can be fatal if inhaled or ingested. After acute ingestion, symptoms such as abdominal pain, burning sensation, nausea, vomiting, salivation, muscle cramp, vertigo, shock, loss of consciousness and convulsion usually appear within 15 to 30 minutes. Acute cadmium ingestion can also cause gastrointestinal tract erosion, pulmonary, hepatic or renal injury and coma depending on the route of poisoning. Chronic exposure to cadmium has a depressive effect and the level of norepinephrine, serotonin and acetylcholine. Rodent studies have showed that chronic inhalation of cadmium, it causes pulmonary adenocarcinomas. It can also cause prostatic proliferative lesions, including adenocarcinomas after systemic or direct exposure. The lung is the most definitely established site of human carcinogenesis from cadmium exposure and other tissues of cadmium carcinogenesis in animal. They include ingestion sites, adrenals, testes and homeopathic system. In some studies, occupational or environmental cadmium exposure has also been associated with development of cancer. The cancer of prostate, cancer of kidney, liver, hematopoietic system and stomach. Carcinogenic metals including arsenic, cadmium, chromium and nickel have also been associated with DNA damage through various mechanisms. It may be DNA pair mutation, deletion, oxygen radical attack on DNA. The next metal which I will discuss is chromium. Chromium, if we say, it is a naturally occurring element. It is present in the earth crust with the oxidation state or valency state which range from chromium 2 to chromium 5. Chromium compound, they are basically stable in trivalent, that is chromium 3. They occur in nature in the states in ores, various ores, for example, ferrochromite. Hexavalent chromium form is the second most stable state. Elemental chromium does not occur naturally. If we see the pathway, the chromium enters into various environmental matrices, whether it is air, whether it is water, whether it is soil, from a wide variety of natural and anthropogenic sources, and the largest release coming from industrial establishment. Industries with the largest contribution to chromium, they release basically their industries are metal processing, tannery facilities, chromate production, stainless steel welding, ferrochrome and chrome pigment production. The increase in environmental concentration of chromium, it has also been linked to air and wastewater release of chromium, mainly from metallurgical, refractory and chemical industries. Chromium is released into environment from anthropogenic activity and other activities. The health hazard associated with exposure to chromium, it depends on its oxidation state, ranging from low toxicity of the metal from the high toxicity of the hexavalent form. All chromium containing compound were once thought to be man-made. Only in chromium 3 it occurred naturally, ubiquitously in air, water and soil and biological material. However, recently natural occurring chromium, hexavalent chromium has also found in ground in surface water at values which are exceeding the World Health Organization limit for drinking water, that is 50 microgram of chromium per liter. Chromium is, as I have told you, is widely used in numerous industrial process and it contaminate various environment portion. Now, I will discuss the mechanism of toxicity and carcinogenicity of chromium. The major factor which governs the toxicity of chromium compound are oxidation state and solubility. Chromium 6 compound or hexavalent chromium, which are powerful oxidizing agent and thus tend to be irritative and corrosive, appears to be much more toxic systematically than chromium 3 or trichromium compound if given similar amount and solubility. Although the mechanism of biological interaction are uncertain, the variation in toxicity, it may be related to the ease with which hexavalent chromium can pass through the cell membrane and its subsequent intracellular reduction to reactive intermediates. Since chromium 3 is poorly absorbed by any route, the toxicity of chromium is mainly attributed to hexavalent chromium form. Now, I will discuss the metal lead. Lead, we all know, it is a naturally occurring bluish grey metal. It is present in small amount in earth crust. Although the lead occur naturally in the environment, anthropogenic activities such as fossil fuel burning, mining and manufacturing contribute to the release of high concentration. Lead has many different industrial, agriculture and domestic applications. It is currently used in the production of lead acid batteries, ammunition, metal product and devices to shield X-rays. Lead in dust and soil often recontaminate cleaned houses and contribute to elevating blood lead concentration in children who play on bare contaminated soil. Today, if we see, the largest source of lead poisoning in children come from dust and chips from deteriorating lead paint or interior surfaces. Children who live in homes with deteriorating lead paints can achieve blood lead concentration of more than 20 microgram per dl or greater. So, exposure of lead basically it occurs through inhalation or of lead contaminated dust particle or aerosol, and secondly to ingestion of lead contaminated food, water and paints. Adult can absorb 35 to 50% of lead through drinking water, and the absorption rate for children is greater, that is more than 50%. Lead absorption is basically influenced by several factors. For example, as I have told in other metal also, age and physiological status. In the human body, the greatest percentage of lead is taken basically by kidney, which is followed by liver and followed by other soft tissues such as heart and brain. However, the lead in the skeleton, it represents the major body fractions. The nervous system is also get affected by lead, and it is most vulnerable target of lead poisoning. Headache, poor attention span, irritability, loss of memory and dullness are the early symptom of effect of lead exposure on the central nervous system. Lead exposure, if we see, it is usually result from lead in deteriorating household paints, lead in workplace, lead in crystal, ceramic industries, ceramic containers that leach it into water, and food lead into some traditional medicine and cosmetics also. Now, I will discuss the mechanism of toxicity and carcinogenicity of lead. The adverse effect of lead in children and adult population have shown an association between blood level poisoning and diminished intelligence, lower intelligence quotients IQ, delayed or impaired neurobehavioral development, decreased hearing activity, speech problem, language handicaps, growth retardation, poor attention span and antisocial and diligent behavior. In the adult population, reproductive effects such as decreased sperm count in men and spontaneous absorption in women have been associated with lead exposure. Acute exposure to lead induces brain damage, kidney damage, gastrointestinal disease, while chronic exposure may cause adverse effect on the blood, central nervous system, blood pressure, kidney and vitamin D metabolism. If you see, one of the major mechanisms by which lead exerts its toxic effect is through biochemical process that include lead's ability to inhibit or mimic the action of calcium and to interact with protein. Within the skeleton, lead is incorporated into the mineral in place of calcium. Lead binds to biological molecule and thereby interfering their function by a number of mechanisms. Lead binds to sulfur hydryl group, amide group of enzyme, and it alters their configuration and diminish their activity. Lead may also compete with essential metallic cation for binding site, thereby inhibiting their enzyme activity, or it affects the transport of essential cations such as calcium. Many investigators have demonstrated that lead intoxication include a cellular damage mediated by the formation of reactive species. The last metal which I will discuss is mercury. Mercury is a heavy metal. It belongs to transition element series of the periodic table. It is unique in that it exists or it is found in nature basically in three forms: elemental mercury, inorganic mercury and organic mercury, which each having its own profile of toxicity. At room temperature, elemental mercury exists as a liquid which is a high vapor pressure and it is released into the environment as mercury vapor. Methyl mercury is the most frequently encountered compound of the organic form found in the environment and is formed as a result of methylation of inorganic mercury forms of mercury by microorganisms found in soil and water. Mercury, if you see, it's a widespread environmental toxicant and pollutant which includes severe alteration in the body tissue and causes a wide range of adverse health effects. Both human and animal are exposed to various chemical forms of mercury in the environment. These forms include elemental mercury vapor, inorganic mercury Hg+, mercuric at G+2 and the organic mercury compound. Because mercury is ubiquitous in the environment, humans, plants, animals all are unable to avoid their exposure to some form of mercury. If we see the sources of mercury, it is utilized in the electrical industry, for example in switches, thermostats, batteries. It is used in dentistry for dental amalgams. It is used in numerous industrial processes which include production of caustic soda in nuclear reactors, antifungal enzyme for wood processing, as a solvent for reactive and precious metal, and as a preservative for pharmaceutical product besides others. Humans are exposed to all form of mercury through accidents, environmental pollution, food contamination, dental care, preventive medical practices, industrial and agriculture operation, and also through occupational operation. The major source of chronic low level mercury exposure are dental amalgam, which we almost all of us go for that, and fish consumption. Mercury, usually it enters the water body as a natural process of gassing from the earth crust and also through industrial pollution. Algae and bacteria methylate the mercury entering the waterways. Methyl mercury then makes its ways through the food chain into fish, then shellfish, and eventually into human through a process of biomagnification. If we see, the two most highly absorbed species are elemental mercury and methyl mercury. Dental amalgam, if you see, it contains over 50% of elemental mercury. The elemental vapor is also highly lyophilic and is effectively absorbed through the lungs and tissue lining the mouth. After Hg enters the blood, it rapidly passes through cell membrane, which include both the blood-brain barrier and the placental barrier. Once it gains entry into the cell, elemental mercury is oxidized and become highly reactive Hg2+. Methyl mercury, which is derived from eating fish, is readily absorbed in the gastrointestinal tract, and because of its lipid solubility, it can easily cross both placental and blood-brain barrier. A major proportion of what is absorbed accumulate in the kidneys, neurological tissues and the liver. All forms of mercury are toxic, and the form of toxicity may be gastrointestinal, neurotoxicity or nephrotoxicity. Now I will discuss mechanism of mercury toxicity and carcinogenicity. The mechanism of toxicity of mercury are based on its chemical activity and biological feature, which suggests that oxidative stress is involved in its toxicity. Through oxidative stress, mercury has shown mechanism of sulfur-hydryl reactivity. Once in the cell, both mercury and methyl mercury form covalent bond with cysteine residue of protein and deplete cellular in oxidation. Inorganic mercury have been reported to increase the production of these ROs by causing defects in oxidative phosphorylation and electron transport at the ubiquitous cytochrome B5 states. Both organic and inorganic mercury have been shown to alter calcium homeostasis, but through different mechanisms. Organic mercury compound, if you see, they are believed to increase intracellular calcium by accelerating the influx of calcium from the extracellular medium and then mobilizing intracellular stores, while inorganic mercury compound increase intracellular calcium stored only through the influx of calcium from the extracellular medium. Mercury compound have also been shown to induce increased level of MDA in both the livers, kidneys, lungs and testes of rat treated with mercuric chloride. These increase in concentration was vitamin E has also been reported against mercury chloride induced lipid peroxidation in the liver. So, after this I will be concluding this session. In this session, as I have discussed the sources of metal in the environment, how they get exposed to human beings, what are their toxic effect, what is the common toxic mechanism and sites of action, and finally I have also discussed mechanism of toxicity and carcinogenicity of arsenic, cadmium, chromium, lead and mercury, which are 5 most toxic metals. Thank you.